Hello friends, welcome to this video lecture. Today we are going to continue the point absorption, intensity shift and UV spectrum, then chromophores and auxochromes, and then factors affecting the absorbance of the organic compounds. In yesterday's video lecture we have discussed principle of UV spectroscopy and the term bathochromic shift and hypsochromic shift. Okay. During the spectrum measurement, spectra is measured in terms of graphical representation, that is energy versus wavelength. Okay, as shown in the graph. ग्राफ मध्ये दाखवले एनर्जी वर्सेस वेवलेंथ यानुसार जो ग्राफ तयार होईल त्यानुसार each and every organic molecule we can find out its lambda max value, that is the maximum wavelength absorbed by organic molecule to carry out the transition of electrons from ground state to excited state in terms of maximum energy or absorption maximum, right? According to this, there are two types of shift. One is the bathochromic shift, red shift. In this shift, maximum that is particular lambda max value is shift towards longer wavelength. It is also called as the red shift. And whenever the lambda max value is shift towards shorter wavelength, then it is called as hypsochromic shift or blue shift. Okay. Now it is clear. Then next one, that is particularly there are two terms involved in this measurement. One is the chromophore and another one is the auxochromes. First you have to remember properly, that is chromophores are nothing but these are the compounds containing covalently bonded unsaturated group which are capable to absorb electromagnetic radiations in UV visible region and impart color to the compound. Okay, chromophore आपण कशाला म्हणतो? You have already studied chromo. Chromo means color. Force means capable. Chromophores are nothing but these are the double bonded system, triple bonded system, multiple bonded system which is covalent conjugated system containing unsaturated groups and which are capable to absorb light radiation in UV region. For example, carbon double bond carbon system, carbon triple bond carbon system, benzene ring system and nitro group in a system. So these are the particular groups. बेंझिन मध्ये हे जे स्ट्रक्चर आहे ए दाखवलेलं आपण, it is containing conjugated system, coherently bonded system, and it is able to absorb some of the light radiations in this region. Such type of particular compounds or group of compounds known as chromophores. That is, chromo means color, force means bearing group, color bearing group. Those particular compounds which are capable to absorb light radiation, and these particular light radiations whenever absorbed, then they show some of the absorbance lambda max value. They are active towards UV light radiations. Okay, that's why alkanes are not able to absorb light radiation. Yesterday we have discussed this point. alkene, alkynes, aromatic compounds, nitro group containing compound. These are the chromophores. Second that is the auxochrome. Auxo means to increase, chromo means color. To increase the color, auxochromes are the saturated groups. It is not necessary to having multiple bond system or double bond system in auxochromic groups. These are the saturated group containing single bonded system or lone pair of electrons when auxochrome attached to the chromophore absorption shift towards higher wavelength. For example, benzene is the chromophore. To this chromophore, whenever OH group is attached, that is, it becomes now phenol. Means phenol containing benzene as a chromophore and OH group as the oxo group. Whenever its lambda max value wavelength is measured, it shifts towards higher wavelength. That means the function of auxochrome is to increase the lambda max value towards higher wavelength. So auxochromes are nothing but these are the saturated group. Whenever attached to chromophore, the absorption shift towards longer wavelength. And therefore, for example, what are the examples of auxochrome? OH group, SH group, methyl group, NH2 group. All these are the groups whenever attached to chromophores, then automatically the lambda max value to shift towards higher wavelength. See the difference? In this slide, three structures are shown. That is benzene A is having lambda max value 255 nanometer, containing only chromophore. To this benzene, whenever OH group is attached, that is OH group is acting as also group. Whenever OH group is attached, the lambda max value is shift from 255 towards 270 nanometers. This is which type of shift now? This is bathochromic shift. So the function of auxochrome is to increase the lambda max value. Absorbance goes on increasing. Same thing happens whenever to the benzene ring system NH2 group is attached, then lambda max value becomes 280 nanometer. So this is particularly the two terms, that is chromophores and auxochromes role. Okay, you are much more familiar to these both terms. Now, the factors affecting absorbance and intensity. Absorbance and epsilon, that is intensity. Which is the first factor? That is A is the conjugation. A is the conjugation, first factor. Whenever any compound contains number of conjugated system, for example, it is structure दाखवलेले. What is the name of these two structures? इथे दोन स्ट्रक्चर दाखवलेत कॉन्ज्युगेशन मध्ये. This is first, second, third, fourth, fifth. It is pentadiene. Both are the isomers of pentadiene. But first isomer shows pentadiene. First isomer shows both double bond. First isomer means which one? That is those which is having lambda max value 270 nanometer. ज्याची lambda max value 217 nanometer आहे. In this pentadiene is 1,3 pentadiene. In this case, both double bonded systems are in conjugation with each other, while its isomer, which is having lambda max value 175 nanometer, inactive towards UV light radiation or less reactive, which is having the structure that a double bond system is not in conjugation with each other. That is, both double bonds are present in terminal position, and that's why the second isomer, that is lambda max value, which is having 175 nanometer, it does not show conjugation. So those compound which is showing conjugated system, that is double bonded system, is in conjugation with each other, the absorption shift towards longer wavelength. They show higher wavelength, and if the double bond system is not present in conjugation with each other, the lambda max value is the less. That is, A is the conjugated system and B is the non-conjugated system. Okay, hope that you understand this point and it is easy to understand. Okay, I will again show this particular, that is conjugated system always shows higher lambda max value and non-conjugated system shows lower lambda max value. Next one, this is the first factor. Second factor is that we know that the well-known equation, that is E is equal to h into velocity of light, that is c divided by wavelength. What is the now relationship? That is, as the conjugation increases, transition energy E between the orbital decreases. Smaller the energy absorbed required for transition, highest is the lambda max value. Simply साधं लक्षात ठेवायचं, those transition requires less energy, transition energy capital E, it shows lambda max value highest. E and lambda max is always reciprocal of each other. Smaller the energy required for transition, highest is the lambda max value. Is it right? Okay. Then second factor is the effect of solvent. Now during the absorbance, what is the effect? During analysis we are using two types of solvent. Play the one. तर एक non-polar solvent system and second one is the polar solvent system. Okay, दोन solvent आपण वापरू शकतो, polar, non-polar. In polar solvent system, transition between pi to pi star requires lower transition energy. See the figure. Figure पहा. Pi to pi star transition takes place in polar solvent system, which requires lower transition energy, less transition energy. Gap is less one. Lower transition energy. That means in polar solvent system, absorbance takes place at higher wavelength. Higher wavelength. While in case of non-polar solvent system, the difference between pi to pi star energy level is higher and required transition is energy is also higher. Higher the required energy for transition state, lower is the lambda max value. And that's why in polar solvent system, particularly the pi to pi star transition towards lower wavelength, whereas because dipole-dipole interaction of polar solvent molecule takes place and while energy required is less. So according to this system, okay, 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 these are the two important themes. That is, because of dipole interaction with polar solvent molecule, lower the energy of excited state than the ground state, and stabilized hydrogen bonding with polar solvent. Hydrogen bond तयार होतो. Right. Sorry, here hydrogen bonding effect is observed in solvent system and required transition is higher. The required transition energy is higher, lower is the lambda max value. In short, again I will repeat, whenever we are going to use polar solvent system, due to polar solvent system, in the molecule hydrogen bonding is developed, and as the hydrogen bonding developed between organic molecule and polar solvent system, the bonding between molecule and polar solvent system becomes strong. Required transition energy is higher to excite from ground state to excited state, and the absorbance shift towards lower lucidity observed. While in case of non-polar solvent system, such type of hydrogen bonding is not observed. And if the hydrogen bonding is not observed, automatically the lower energy is required for transition, and automatically lower energy required for transition, it shows highest lambda max value, that is shift towards bathychromic shift. Okay, so these are the two factors. म्हणजे आपण जर पोलार सॉल्व्हंट वापरलं तर ब्ल्यू शिफ्ट ऑब्झर्व होते ड्यू टू प्रेझन्स ऑफ हायड्रोजन बॉन्डिंग विथ ऑर्गॅनिक मॉलिक्यूल अँड solvent system. And if non-polar solvent system is used, for which transition is important now, pi to pi star, then bathychromic shift is observed due to lack of hydrogen bonding, right? In case of n to pi star transition, in case of n to pi star transition, polar solvent shows same effect, that is shift towards lower wavelength, because dipole-dipole interaction with polar solvent molecule lowers the energy of ground state than that of the excited state, and automatically the particular shift is observed. So non-polar particularly polar मध्ये जी कंडिशन आहे ती इथं पाहायला मिळते, हा गॅप कमी पडतो आणि शिफ्ट आपल्याला त्या टाईपची पाहायला मिळते. ओके, so according to this, what is the effect? That is, blue shift means lower lambda max value, highest energy is required. Okay, because dipole interaction lower the energy to ground state. Okay, okay, ठीक है. So according to this, these are the two factors which affect the particular nature. Okay, okay, thank you. This is our first half